Hello and welcome. Our global communication networks, the very things that connect all of us, are getting to a point where they are just unbelievably complex. We're talking about a level of complexity that is starting to outpace our human ability to manage it effectively. It's a silent crisis brewing in the background of our digital lives. So that leads to a really profound question. How do you give a network a brain? It sounds like science fiction, but it's becoming an engineering necessity. Today, we are going to dive deep into the architectural blueprint for doing just that, for infusing our global networks with artificial intelligence. And make no mistake, this is an incredibly high-stakes endeavor. Getting it right will define the future of communication, of business, of society itself. So, let's get right into it.
Okay, so here's the roadmap for our journey today. We've structured this to build the story from the ground up so you can see how all the pieces connect. First, we're going to start with the why. We'll explore what we're calling the telco tipping point, the immense business and technology pressures that are forcing this massive change. Then we'll get our hands dirty. We'll move from the boardroom down to the server room and deconstruct the real-world practitioner challenges. What are the engineers and data scientists actually struggling with every single day? Once we understand the problem, both from a high level and on the ground, we can start talking about solutions. That brings us to the vision of a digital brain. What is the North Star? What is this aspirational goal we're all trying to build towards? With that vision in mind, we'll lay out the E2E framework blueprint, the actual architectural plan to build it, layer by layer. Now, woven through that entire blueprint is arguably the most important piece of the puzzle, dissecting responsible AI. We'll spend a good amount of time here because without trust, none of this works. And finally, we'll wrap up with a call for community action, because this problem is simply too big for any one company to solve alone. It's a packed agenda, so let's begin.
All right, Section 1, the telco tipping point. Before we can even begin to appreciate the elegance of a solution, we have to have a deep, almost forensic understanding of the problem it's trying to solve. So in this first part, we're going to really unpack the immense pressures, the perfect storm of challenges that are pushing the entire telecommunications industry towards AI. The big question we're answering here is, why this, and why right now?
This really is the foundational question for everything we're going to talk about today. It's twofold. First, why are we even talking about putting AI in charge of our networks? And second, even if we accept that, why do we need a whole dedicated framework? Why not just buy a few AI tools off the shelf and call it a day? The answer to both is that the industry is caught in a perfect storm. On one side, you have these relentless rising costs. On the other, you have this crushing exponential growth and complexity. And these two forces are squeezing the traditional human-centric way of managing networks to its absolute breaking point. It's just not sustainable anymore. Let's start by following the money.
40%. I want you to just let that number sink in for a moment. 40%. This single figure is what keeps telecom executives up at night. This is the average percentage of a telco's total cost that is spent just on operating the network. That's called OPEX, or operational expenditure. Think about that. Before you've invested a single dollar in a new 6G tower, before you've developed a new service, before you've made a profit, 40 cents of every dollar is already gone just to keep the lights on for the existing infrastructure. It's a massive, massive financial anchor dragging down the entire industry. And when you have a number that big, you can't just trim around the edges. You can't just find a few percentage points of savings here or there. To have any hope of making a real dent in that 40%, you have to fundamentally change how you operate. You have to move beyond the limitations of purely human-led operations and introduce a new, more scalable kind of intelligence into the system.
So where does that staggering 40% actually go? Let's break it down. First, you have network maintenance and monitoring. Picture a massive network operations center, the size of a football field, with screens everywhere, filled with engineers watching for alarms 24/7, 365. That's a huge ongoing human cost. Then there's customer support and billing. We're talking about colossal call centers and incredibly complex billing systems trying to handle millions of customers. Next up, field operations and repairs. This is what the industry calls the truck roll. Every time a piece of equipment fails, you have to pay for a truck, fuel, and a highly trained technician to drive out and fix it. It's incredibly inefficient. Then there's the invisible giant, power and cooling for all that infrastructure. Data centers, cell sites, they consume an enormous amount of energy, and those bills are only going up. And finally, software licensing and upgrades. The network runs on complex software, and those licenses and mandatory upgrades from vendors add up to a huge bill. Each of these is a massive cost center on its own. And the terrifying part? They are all getting bigger because the network itself is getting unimaginably more complex.
And this, right here, is the other jaw of the vice.
The costs are rising because the networks themselves are becoming impossibly complex. This isn't your old phone network anymore. We're in the middle of a transition from 5G to 5G Advanced and already planning for 6G. We're pushing computing power out to the edge of the network to enable things like autonomous cars and real-time augmented reality. We're shifting from physical hardware boxes to flexible software-defined networks that can be reconfigured on the fly. Each one of these incredible innovations adds another layer of complexity, another 1,000 variables, another 10,000 potential points of failure. Trying to manage this explosion of complexity manually is like trying to conduct a 1,000-piece orchestra with a tiny whistle. It just doesn't work. The scale has surpassed human capability.
This relentless acceleration is the final piece of the pressure cooker. Just look at how fast things are changing. Back in the 1980s, a major technology cycle, like the move from analog to digital, lasted more than a decade. You had time to plan, to deploy, to recoup your investment. Fast forward to the 2000s with the rollout of 3G and the rise of the mobile internet, and that cycle shrank to about 7 years. Still manageable. But today, in the 2020s, a full technology generation is less than 5 years, and that window is still shrinking. Companies are in the middle of massive, expensive 5G deployments, and their research labs are already deep into 6G. There is absolutely zero room for error, zero time for inefficiency. You have to operate at machine speed. And this is the environment, this perfect storm of cost, complexity, and speed that makes AI not just a nice-to-have, but an absolute survival imperative.
Okay, Section 2, Deconstructing Practitioner Challenges. So, we've just painted the big picture. We've seen the massive, industry-wide pressures from the 30,000-foot view. Now let's zoom all the way in. Let's move from the boardroom to the server room, from the executive summary to the command line. What are the real, on-the-ground, day-to-day hurdles for the engineers, the data scientists, the developers who are actually tasked with building and deploying these AI solutions?
When you talk to the people on the front lines, you find that their struggles, their gauntlet of challenges can be boiled down to 5 critical domains. First and foremost, there's data. Then comes the ever-present reality of cost. Third is the crucial and evolving challenge of security. Fourth, and often the trickiest, is the organization itself, the people and the culture. And finally, you have to actually prove the value with concrete use cases. We're going to spend the next few minutes doing a deep, forensic analysis of each one of these hurdles.
First up is data. You've probably heard the phrase, data is the new oil. Well, for AI, it's more fundamental than that. It's the new oxygen. Without a steady supply of high-quality data, your AI initiatives simply cannot survive. Now, networks generate an almost unbelievable amount of data, petabytes upon petabytes every single day. But here's the catch. Just having a giant mountain of data isn't enough. In fact, it can be a liability. The data has to be usable, it has to be accessible, and it has to be trustworthy. And this really breaks down into 3 key pillars that every practitioner has to build on.
Those 3 pillars of data readiness are availability, quality, and integrity. Let's look at each one. First, availability. Can you even get to the data you need? So often, it's locked away in proprietary vendor equipment, in what we call data silos. Different departments might own their data and be unwilling to share. Just getting access can be a huge political and technical battle. Second, quality. Even if you get the data, is it clean? Or is it full of errors, missing values, and inconsistencies that will lead your AI model astray? The iron law of machine learning is garbage in, garbage out. If you train your model on bad data, you will get bad results. Guaranteed. Finally, there's integrity. Can you fundamentally trust that the data hasn't been corrupted or tampered with, either accidentally or maliciously, on its journey from the sensor to your model? Without these 3 pillars firmly in place, any AI project you try to build is resting on a foundation of sand, and it's destined to collapse.
Okay, let's say you've somehow managed to solve the monumental data problem. You have clean, accessible, trustworthy data flowing. The very next thing you're going to hit is a giant brick wall of financial reality. That's our second challenge, cost. The grand vision of an intelligent, AI-powered future often has a brutal collision with the hard numbers of a quarterly budget. Building and operating AI at this kind of scale is not cheap. It requires significant, sustained investment.
These huge costs really come from 3 main areas. First, there's the raw compute infrastructure. To train the kinds of deep learning models we're talking about, you need massive clusters of very expensive, very specialized processors called GPUs. The demand for these is through the roof. Second, you need specialized platforms. This isn't just one piece of software, it's an entire ecosystem of tools, often called MLOps, or machine learning operations. These platforms help you manage the entire AI lifecycle, and they come with hefty licensing and support fees.
And third, and this is a big one, there's niche talent acquisition. The people who know how to do this stuff, the data scientists, the machine learning engineers, the AI architects, are some of the most sought-after professionals on the planet. A telecom company finds itself in a global bidding war for talent against every tech giant from Silicon Valley to Shanghai. The third challenge practitioners face is security. And I want to be really clear here. This is about so much more than just preventing data breaches. It's about establishing fundamental trust in the system. Remember what we're talking about, giving AI a degree of control over critical national infrastructure. The systems that power our hospitals, our banks, our emergency services. If the public, and just as importantly, if the regulators don't trust the security and reliability of this AI-driven network, the entire initiative is dead in the water. It fails before it even gets started.
The security landscape for AI today is incredibly complex and layered. At the very bottom, you have foundational data privacy. This is table stakes, protecting customer data, complying with regulations like GDPR. But now, with the rise of large language models, or LLMs, you have to deal with entirely new emergent LLM privacy risks. What happens if a clever hacker can trick a network chatbot into revealing configuration details or network vulnerabilities? This creates a completely new attack surface that we're only just beginning to understand. All of this leads to the much broader mandate for what we call responsible AI, where security is just one part of a bigger picture of creating systems that are safe, reliable, and trustworthy.
This brings us to our fourth challenge. And in many ways, it's the hardest one to solve because it's not about technology, it's about people. It's the organization itself. You can have the best data, the biggest budget, and the most secure platform in the world. But if you don't have the right people, the right processes, and the right culture to support it, your AI initiative will absolutely fail. It will wither on the vine, stuck in an endless loop of pilot projects that never see the light of day. So what does organizational readiness look like? It means addressing the people. You need to upskill your existing network engineers who have decades of priceless domain knowledge and teach them the fundamentals of data science. It means changing the process. You can't just drop an AI recommendation into a decades-old workflow. You need to create new, safe processes that integrate AI-driven insights, often with a human in the loop to start. And most importantly, it means shifting the entire corporate culture. You have to move from a culture that runs on gut instinct and tribal knowledge to one that trusts data, that isn't afraid to experiment, and that sees AI not as a threat, but as a powerful new tool for its employees. And that brings us to the fifth and final practitioner challenge, finding and proving out viable use cases. In the corporate world, technology for technology's sake just doesn't fly. You can't just say, AI is cool, we should do some. Every single AI project needs to have a clear, compelling business justification. It needs to solve a real problem and deliver a tangible, measurable return on the massive investment of time, money, and people. Ultimately, proving the value of an AI use case comes down to answering yes to three critical questions. First, ROI. Can you demonstrate a clear financial return? Will this project make money, or more likely in the OPEX world, save money? Second, efficiency. Does it result in measurable operational gains? Does it make the network run better, faster, or more reliably? And finally, feasibility. Is this actually technically possible today with the data and technology we have, or is it a science project? You have to get a clear and convincing yes on all three of these: ROI, efficiency, and feasibility. If you get a no on any one of them, the project is likely dead on arrival. All right, Section 3, Vision of a Digital Brain. We have spent a lot of time mapping out the battlefield. We've looked at the immense pressures and the daunting challenges. Now let's pivot. Let's start talking about the solution. To build something this ambitious, this complex, you absolutely need a clear, unifying vision. You need a North Star that everyone can align to. And in this world, that vision, that ultimate goal, is the concept of the network digital brain.
So what exactly do we mean by a digital brain? Let's break down this definition. At its core, it's a centralized system. That's key. It's designed to break down those data and organizational silos we talked about earlier. And its job is to orchestrate. It's the conductor of the orchestra. What does it orchestrate? All the key components. The network data flowing in, the library of AI models, the collections of prompts for generative AI, and the end-user applications. And what is the purpose of all this orchestration? To enable intelligent and eventually autonomous network operations. Think of it just like a human brain. It takes in vast amounts of sensory input from the network. That's the data. It processes that input by accessing learned patterns and knowledge. Those are the AI models. And then it directs the body, the network itself, to take action through the applications. This is the ultimate aspirational goal. Okay, Section 4, the E2E framework blueprint. So, we have our North Star. The digital brain is our destination. The next logical question is, how do we get there? How do we actually build this thing? What does the architectural blueprint look like? Now we're going to move from the what to the how and lay out the plan, layer by logical layer.
The best way to think about this framework is as a 4-layer stack, kind of like a cake. At the very bottom, you have the foundation, the data layer. This layer's job is to ingest, clean, store, and manage all the raw data coming from the network. Sitting right on top of that is the models layer. This is the workshop where the AI models themselves are actually built, trained, and refined using the data from the layer below. Now, the crucial layer in the middle, the glue that holds everything together, is MLOps. This is the control plane. It's responsible for the control, orchestration, and management of the entire lifecycle of the models. And finally, at the very top, you have the applications layer. This is the user interface. This is where human engineers interact with the system, see the insights, and either approve or take action based on the AI's recommendations. But here's the thing. This 4-layer stack isn't the whole story. There's a 5th, critical element. And it's not another layer that you just stack on top. It's a principle, a set of practices that must be embedded within every single part of the framework, from the bottom to the top. It has to cut across everything. And that all-encompassing principle is responsible AI.
Section 5, Dissecting Responsible AI. This brings us to what is arguably the most critical component for the success of this entire endeavor. Now, responsible AI is a very popular buzzword these days, and it's easy to dismiss it as just marketing fluff. But what does it actually tangibly mean in the high-stakes context of a national communication network? It's everything. Because without it, there is no trust. And without trust, there will be no adoption. It's that simple.
This survey of C-suite executives tells a very stark and worrying story. Just look at these numbers. Nearly 9 out of 10 executives, 89%, are worried about the security risks of AI. A full 70% openly admit that their company needs a formal policy to manage AI. So the awareness of the problem is there. But then look at the last number. Less than 1 in 4, only 24%, believe they actually have some kind of framework in place to manage it. That's not just a gap, it's a chasm. It's a giant void between high-level anxiety and concrete action. And it's exactly this void that a standardized open framework is designed to fill.
Let's just pause on this single data point for a second, because it says everything. Only 24% believe they have some framework. What this tells you is that the vast majority of the industry is diving headfirst into this powerful new technology without the necessary guardrails, without the safety systems. It's like building a fleet of supercars and sending them out on the highway with no brakes and no steering wheels. That's why a common, open, and robust framework for responsible AI isn't just a good idea, it's an absolute, non-negotiable necessity for the entire industry.
So, what does a responsible AI framework actually look like in practice? What are its components? It's really built on 4 foundational pillars. First, enhanced security, which we've discussed. Second, robust data privacy protections. And then there are 2 more that are especially important for building trust in complex AI systems: explainable AI, or XAI, and fairness and bias mitigation. Let's take a closer look at these last 2 because they are so crucial for getting human experts to trust and adopt these new systems.
Explainable AI, or XAI, is the antidote to the black box problem. Many powerful AI models are incredibly complex, to the point where even their creators don't know exactly why they make a specific decision. That's a black box, and it's completely unacceptable in a critical network environment. If an AI recommends a major action, like rerouting all the internet traffic away from a major city, the network engineers must be able to ask the system, why did you suggest that? Was it because you detected a massive security threat? Or was it just a faulty sensor feeding you bad data? XAI is the collection of techniques that opens up that black box, making the model's internal reasoning understandable to a human expert. Without it, there's no trust, there's no accountability, and there's no adoption.
Fairness and bias mitigation is just as critical, though sometimes in more subtle ways. AI models learn from the data we give them, and if that historical data contains hidden biases, the AI will learn those biases and, even worse, amplify them at scale. For example, imagine an AI model that helps decide where to invest in network upgrades. If it's trained on historical data that, for whatever reason, consistently favored investment in affluent areas, the model will learn that pattern. It will then recommend continuing to underinvest in lower-income communities, accidentally creating a deeper digital divide. The process of fairness and bias mitigation is about actively finding, measuring, and correcting for these hidden biases in the data and the models to ensure equitable and fair service for all user groups.
Section 6. A call for community action. All right, we have covered a lot of ground. We've gone from the high-level theory and the immense problems all the way down to the nitty-gritty of the architectural blueprint and the principles of responsibility. Now, for our final section, let's look at the practice. How does this grand vision for a framework actually become a reality? It starts with open-source communities and what's called seed code.
2 open-source projects form the foundational seed code for this framework. The first is called Project Assetum. This project provides the core orchestration. It's the MLOps engine room we talked about. It has the model catalog, the data science workbench, the assurance tools, all the machinery. The second project is called Salus. This project provides the critical guardrails for responsible AI. It has the APIs and tools for implementing security, privacy, explainability, and fairness. I love the analogy of a car. If Assetum is the powerful engine, the chassis, and the transmission, then Salus is the advanced braking system, the airbags, the seatbelts, and the steering wheel. You absolutely need both to move forward quickly and safely.
And this is an absolutely crucial point that the leaders of this initiative make. What's being offered here isn't some finished, polished, off-the-shelf product. These are seed codes. They are a powerful, well-architected starting point, a solid foundation. But they are not yet fully hardened for the unique, demanding, carrier-grade environment of a telco. That hardening, that process of testing, improving, and adding features, that is the job of the entire community. It's an open invitation to telecom operators, to equipment vendors, to academics, to everyone, to come together, collaborate, and build this future collectively.
And so we come to the end of our deep dive, and we're left with a final provocative thought. We have spent this entire time architecting the how to build this digital brain, how to manage it, how to make it responsible. But as we embark on this journey, we must constantly grapple with the much deeper question of who. If a network truly has a digital brain, who is ultimately responsible for its thoughts, for its decisions, for its inevitable mistakes and its unforeseen consequences? This isn't just a technical question for engineers. It's a profound ethical and societal question that we all must answer together. Thank you for joining me.